Hello, welcome back to our channel Trade Topic. Today we continue last video lecture of Basic Mathematics Unit 2 of GTU Semester-1. In last lecture we explained what we covered in Determinants and Matrices of GTU syllabus. Determinants. Today we start from determinants. Determinants, second order determinants. Second order determinants is denoted by A1, B1, A2, B2. This is called second order determinants. And A1, B2 minus B1, A2 is called value of determinants or expansion of determinants. So there are four properties of determinants. First property is the second order determinants are made by four elements: A1, A2, B1, A2. Okay. Second, there are two rows, two columns. A1, B1. A1, B1 is row number 1. A1, B1 is row number 1. A2, B2 is row number 2. There are two columns. A1, A2 column number 1. B1, B2 column number 2. Okay. Second property complete. Third property. A1 and B1 are element of row 1. A1 and B1 are element of row 1. A2, B2 are element of row 2. Third, A1, A2 are element of column 1. B1, B2 are element of column 2. And fourth, value of determinants is equal to A1, B2. Value of determinants is equal to A1, B2. A1 into B2 minus B1 into A2. B1 into A2. Okay. So let's start example upon second order determinants. First example 2, 1, 3, 5. First example. Two, 1, 3, 5. So for finding second order determinants of these 2, 1, 3, 5, first we compare this with this A1, B1, A2, B2. Here A1 means 2. Here A1 means 2. A2. Here A2 means 3. B1. B1 means 1. And B2 means 5. So according to this equation, A1, B2 means 2 into 5 minus B1, A2. B1 means 1 and A2 means 3. 1 into 3. 2 into 5, 10 minus 3 is equal to 0. Okay, this is our answer. Second, x minus y, y, x. X minus y, y, x. Same for finding this A1, B1, A2, B2. Here A1 is x, A2 means y, B1 means minus y, x means b2. So a1 b2 means x into x into x minus b1 a2 means minus y into y into y equal to x square minus minus plus y square. This is our answer. Third, sin theta minus cos theta sin theta minus cos theta sin theta. Okay, sin theta. Again compare a1 comparing with this a1 b1 a2 b2. Okay, a1 means sin theta and sin theta b2. a1 b2 means sin theta into sin theta into sin theta. Sin negative b1 a2. b1 means this minus cos theta and cos theta minus cos theta cos theta. So here sin square theta minus and plus minus and minus plus then cos square theta is equal to 1. The equation. Fourth example. Prove cosec theta cot theta cosec theta is equal to 1. We want to prove this is equal to 1. So let's take LHS cosec theta cot theta. Cot theta cosec theta. This is LHS. So here comparing a1 means cosec theta, b1 means cot theta, a2 means cot theta and cosec theta means b2. Okay, for finding this cosec theta into cosec theta, cosec theta into cosec theta. Minus cot theta into cot theta. This is equal to cosec theta minus cot square theta. Cosec square theta minus cot theta. It means cosec square theta is equal to 1 plus cot square theta. Cosec square theta is equal to 1 plus cot square theta. Cosec square theta equal to 1 upon cos square theta and again sin square upon cos square theta. 1 plus cot square theta minus cot square theta is equal to 1. Okay, we prove RHS is equal to 1. Last example. Solve the equation x minus 2 3 x plus 2 is equal to 0. Here we find value of x. Okay, so first take x minus 2. So x minus 2 3 4 x plus 2. Here x minus 2 into x plus 2. So x minus 2 to x plus 2 minus 3 into 4 equal to 0. So x minus 2 x plus 2 means a plus b a minus b is equal to a square minus b square. A plus b a minus b is equal to a square minus b square. So x square minus 4 minus 12 is equal to 0. minus 4 minus 12 means minus 16. So 16 to RHS side. So x square is equal to 16. So x is equal to 4. In next video, we continue determinants of